Yeah, let's start. The stage is yours.
Okay, welcome guys. This is the Polygon Discord AMA with Cartesi. We have with us Milton Jonathan. He leads the product engineering team at Cartesi. We'd love to hear a little bit about you, the team, and a little bit of a background for everyone who is just joined and doesn't know maybe what Cartesi.
Great, thanks. Great to be here. Thanks for having me. So, as Harry has said, I'm currently leading the Cartesi's product engineering team, which is, among other things, we are focused on exploring solutions on top of Cartesi's core technology so that we can showcase the potential of this technology and expand the possibilities of what the community can build on top of it, right? So just to give some background on Cartesi itself, Cartesi is a layer 2 solution that basically allows people to create complex decentralized applications using mainstream tools and libraries. So the idea is, I'm still preserving the security guarantees of an underlying blockchain, right? So the uniqueness of what we do is that we are based on a very specific and sophisticated deterministic VM, which is based on the RISC-V architecture, and as such is capable of running an entire Linux operating system. And so we aim to make it possible for decentralized applications logic to be executing on Linux, still preserving the security guarantees of a blockchain. And so we envision that this will create a vast array of new possibilities for that.
Got it. So basically you guys allow mainstream developers to use their mainstream softwares, their software stacks instead of Solidity to create smart contracts, right?
Exactly, yes. And one of our goals is to bridge this gap between the blockchain development community and the mainstream development community, which is millions and millions of people which are out there and currently have this barrier to get into the blockchain space. And so with more people, we'll have much more action in the space and bring these decentralized applications to its full potential.
So I heard you guys are building a poker game with Cartesi. So why exactly, why a poker game especially? Is there some relevance to that?
Yeah, actually there is. So, well, first of all, online poker is really popular. So people are playing that. Millions of people play it every time. But the centralized poker platforms, they have had some trust issues in the past. So there have been cases of super user accounts where people were helping, cheating by poking into the people's private cards. And so this has what we've learned is that there are lots of people who really love to see a fully decentralized poker game where this kind of issue doesn't happen anymore. But actually, that's something that nobody has been able to do so far with the current blockchain technology. And so we realized that this would be a nice use case to showcase what can be done with Cartesi, right? And because we realized that with Cartesi, we could bring a solution, a fully working decentralized solution to this problem.
But there are already so many blockchain poker platforms, right? I mean, when you say fully decentralized, can you explain that a little bit more and like how it is different from the other poker platforms?
Right. Yeah. I'm not sure how many there are. There are a few. But when we look closely, and the poker community does look closely because they want to have a really cheat-free version of online poker. And when you look closely, there are some platforms there where you play poker on the blockchain, but up to a certain point, if the players disagree among themselves and there's a dispute, then so far none of those have come up with a really robust mechanism that allows a dispute to be resolved without having some centralized authority in the middle. So in general, you have a dispute and you have some validator nodes that will check. But if the validator nodes disagree among themselves, then they just resort to some central authority and decide what to do. So in the end, people still have to trust somebody, and we believe that's not what people are really looking for. That's not what they want. So in the end, what we aim for is a fully decentralized, that in no circumstances you need to put somebody in to solve the issue.
Okay.
Because yeah, the stakes are high enough, and often they are, right? So the same circumstances that allow a popular centralized poker to platform to be open to this kind of issue will end up bringing the same problem to this other solution. So it has to be fully decentralized for people to really trust it.
Okay. I mean, you mentioned that poker players have to like rely on a centralized body, right? So how exactly does Cartesi help in terms of like decentralizing that aspect of it and prevent like say rigging or like you mentioned, looking into other players' whole cards?
Yeah.
So yeah.
So this is really fun from a technology point of view. There's been a lot of academic research in this kind of problem for the last decades, actually. And there's a set of cryptographic protocols that's popularly known as mental poker, in which people use some zero-knowledge proofs to basically allow two people to shuffle a deck of cards, and they stand it to each other. And in the end, nobody's able to see which card is which unless they collaborate. And this works. Actually, people devised this to play in the 60s by postal mail. But the issue is that this solves not having people playing together without an external party and being able to play along without knowing which cards the other guy has. But the issue is still, if there is a dispute, if somebody stops collaborating, or if he refuses to reveal a card, if he claims that he won and he didn't, then you need some like judicialization of the issue, right? Something has to come in and solve it. So of course, we're already here in the blockchain space, so we know that the right way to do it is to run it on the blockchain, right?
Correct.
But these algorithms, they are pretty resource intensive and sophisticated. You need to encrypt and decrypt and generate proofs and validate those proofs. And this is simply impossible to run on a layer 1 blockchain. And we found out that, well, we came to realize that Cartesi would be really something that we could help to run this in a decentralized way in the blockchain and solve a dispute like that.
Right. So, guys, if you guys have any questions, I would request you all to go to voice chat, which is another tab right above this, and put down your questions as and when you get them, because it may be hard to remember or whatever, but we'll take questions in a short bit. So please start putting up your questions so that, I mean, we can answer them post this. Right. So coming back to this, Milton, you were saying, so there's too much validation to do, so you can't use layer 1s like Ethereum. So but there are other layer 2s also, right? I mean, why can't you just use another layer 2?
Yeah. So there are other layer 2 solutions out there. And actually that's great, right? There are many projects that are trying to scale Ethereum and other blockchains. But the thing is, to solve this issue, it's not just about running a Solidity smart contract faster and cheaper, right? And this is what most layer 2 platforms are doing, which is great and necessary. But for this kind of issue, it's not only resource intensive, but the code is really complex. And so even if you have a layer 2 solution, which is performant enough to really run the algorithms in a reasonable amount of time. Not all of them would, but some of them might. But there's still the problem that you have to write the software. And this software is not easy to write. So, and this is where we think Cartesi makes a huge difference, because since we have this Linux-enabled VM, you can actually use software that's already out there. It's standard libraries that are already battle tested. They have been written and tested for years. You don't have to write them from scratch, right? And that's a huge difference.
So you're saying it helps with scalability on one end and efficiency and productivity on the other end?
Yeah, that's right. And you could actually add to that a security aspect as well, because if you're writing something from scratch, like an encryption algorithm or proof validation or something like that, and you have to write that from scratch, it will, of course, be more expensive for your development team. You have to allocate lots of people to do it. But in the end, what would be safer, right? To run something that you just wrote and hasn't been tested yet, or just use some standard library that's available in Linux, and there's a huge community supporting it, and it's been battle tested. So for poker, for instance, we use the library called libtmcg. It's a toolbox full of algorithms that came out of academic research. It's been around for many years. And so this is something that we trust is solid enough to be used, as compared to something that we or somebody else would take some time to develop and then would need some years maybe to mature, right?
That makes a lot of sense. But okay, but let's talk more about the Cartesi's poker implementation specifically. Can you tell us what's part of the package and how things work and stuff?
Right. So a month ago or so, we released our first version of the code for poker. It's actually based on the solution that we put out at the moment. It has three main parts. First of all, there's a web application, which is kind of standard, but it's the front-facing UI for people to play with the game. It runs in the browser at the moment. And the second part of the solution is a number of smart contracts that we have already deployed to Polygon's Mumbai testnet when they are there. And then the web app interacts with these contracts, right? And then there are the third part of the solution is a number of Cartesi validator nodes. Cartesi is a Cartesi SDK for developing applications that we have already set forth. And they are the validators node that will be capable of running the entire game inside a Cartesi machine, which is a verifiable computation, and to solve any disputes. And one important thing to feature here is that the Cartesi technology allows any trust guarantee. So if you have like 10,000 nodes and there's only one honest one, the honest one will win, and he will be able to enforce the correct result. So the poker solution that we have, the general workflow is as follows. The guy would open the web app, he would submit transactions to the smart contracts to join a game, and then lock tokens in it for the poker game. And then the people interact with each other, sending, shuffling the deck and encrypting it, and revealing the cards and betting. And the game progresses like that. In the end, according to the outcome, the tokens are given back to the players according to who won and who lost, right? And there are some limitations right now. This is a showcase. We are limited to Heads Up Texas Hold'em, which is only 2 players. Yeah. And the code that we set out there is using some poker tokens that we just created for this game. They have no real value, but the code is there on the repository. Anybody can check it out. And the code generally allows for any ERC20 token to be used, but we are only putting forth a version that accepts poker tokens. And so people can just check out the code and play around with it, and even actually develop other games, because the framework that we developed for poker can also be used for other games besides it.
Got it. That's so useful. Guys, if you have any questions, please use the voice chat. Put in your questions and we'll get to them very, very soon. Okay, so coming back to this, you've explained the basic structure and how a user would interact with it, etc. But can you tell us more about the framework, like the actual logic and like...
Right.
Yeah.
So the logic of the game itself, as I said before, is using this toolbox, this libtmcg toolbox, which is written in C++. And so it has some number of dependencies as well, like crypto and some others. So this is the main logic of the game, which we call the poker engine, right? And this runs both on the player's devices, so the browsers, and also in the validator nodes inside Cartesi machines, should there be a dispute to resolve the dispute. So the logic runs there. The smart contracts that we deployed on Polygon, they are actually not specific to poker. When we developed the game, we found out that we didn't need to put any logic in there. The smart contracts are basically used to people to join a game, so it matches players and they start a game, they lock their tokens there, and then it mediates interaction between the players. In the end, it transfers the tokens back to them. And if necessary, so if somebody complains about some misbehavior, it can fire the Cartesi computation that will trigger the validator nodes to run the full game and get the correct output and punish a misbehavior. So this means that if you want to create another game, you just create the logic in any language that you want, anything that runs on Linux. So you can create it in Python, on C++ as well as we did, on JavaScript or something else. And you create a front-end application, of course, for it, right? So people can play. And you just pack it inside a Cartesi machine for dispute resolution. And that's it. So we think that this is also a way to showcase, because poker is a nice use case where you really need this kind of reuse of existing mainstream technology and also scalability. But we think that it's also interesting in terms of productivity, as you said, that you could just write your game and you don't even need to code in Solidity, and you could get something else running. So in the same repo for poker, we just did a chess game where we just took a JavaScript chess library called chess.js, and easily just you play the chess game there, and it verifies the results to people. One says it has a checkmate, the other disagrees, and you just run the game there, and it decides who you can see who won.
That is amazing. That's so cool. I just want you to let people know how they can get started with this solution. Like, how do they get access to information and like what to do next?
Right. So we put out a Medium article a while ago. I'm not sure where's the best place to paste the link. Maybe we can put it here at some point. It's a Medium article called How Cartesi is Changing the Game. Introducing Cartesi Texas HODL'em, which is the name of this showcase poker game. And that one explains the overall architecture of the game and the motivations, so much in line with what I just said here. There is a second article which is interesting for developers, which takes a deeper dive into this framework that I just talked about, this turn-based game framework, which allows any turn-based game, because we're talking about games that are not real-time, right? So once one player submits a move or a turn, and then the other one responds, etc. So you could think about battle strategy games, other card games, any game like chess or things like that, where each player interacts one at a time. And so there is a second article where we explain in a little bit more detail how the framework works and how chess was made. And also, of course, there's the code on GitHub, which I encourage people to check out and download and play around with. And then you can also run the game itself, right? And check how the details of the code for the verify that we did for chess, or create your own game.
So I think we should kind of provide these guys with these articles and the code from GitHub, at least the links on the voice chat. Let's get to it soon.
I have added those links.
Oh, okay. Sandeepan to the rescue. Okay, so but I really want to see what you see gaming and the future of gaming on blockchain in Cartesi's vision. Can you just let us know a big picture in your eyes?
Sure. So as we see it, as I said before, our vision is to bridge this gap, right, between what the blockchain community that develops applications and games in particular, and the wider mainstream community, so that with more people and more resources, much more can be done. And so there's one aspect that we see, that whether it's Cartesi or somebody else, but we think there's a necessary step to get all these people who are developing games, who are learning how to program, right, and becoming developers. They need to have an easy way in, because it's still a little bit hard for people from the mainstream industry to start coming into blockchain. We've seen so far not so much of the mainstream gaming industry really dive into blockchain. They are going through the NFT angle, things like that, but really to have a full game running, still starting, right? So we think there's something that needs to be done to help bridge this gap, and we think that getting all these resources that are available out there, both in terms of funding and in terms of software stacks that are already out there, we think that this could be brought inside. And also there's not only bringing these people inside, but also making some games that are currently simply impossible to even imagine. One of our visions within Cartesi is that we want to make those impossible games possible, right? We want to make things that people don't even consider creating right now. We want to expand that possibility.
So can you give us maybe what other kind of applications can be integrated into the SDK? Some examples that you're working on.
Sure. And just to complement on the last question, we think it's a combination, right? So we'll still be using an underlying blockchain. So we think it's a combination of all the projects that are out there that will combine themselves so that we can run Solidity contracts faster and cheaper, as Polygon allows, that other people, and it's fantastic, it's necessary. And then getting mainstream software components into the fold, and maybe combining other technologies, maybe state channels and other things. So all of these are valid. But we need to wrap it up in a way that people are convenient to use, right? And so for other applications, we see lots of possibilities. The major, there are, of course, there are always things that you can imagine doing in a blockchain space, but not necessarily there's a demand for that. Maybe you need applications that have this requirement, right, of being decentralized. But we see a number of things. So, for instance, you could have machine learning or AI based applications. So you could imagine somebody, I don't know, uploading some photographs, and you need to check out or do some machine learning on top of it to, for instance, see if it's a tree or if it's a cat. And you can run maybe such an algorithm inside a Cartesian machine, check out if the classification is correct or something like that. It's something that we don't really envision right now, right? Nobody's thinking about running image classification in a blockchain because it's simply impossible. But this is the kind of thing that maybe we could help bring to reality, right?
That's amazing. So I think let's look at what the community has to ask you. I've been getting DMs. Can you guys please use the voice chat to send your questions? I got a question on my DM, which is where does Cartesi see itself in 10 years? Are you going to be centralized or a DAO?
Oh, we want to be decentralized as much as possible. 10 years is such a long time that we think all the projects will be transmuted into something else by then, right? Either they will be merged with some others. Anyway, but our goal is, we're a foundation, right? So our goal is to help bring blockchain to this next level. So be it Cartesi tech or be it something similar, we think that something similar to what we're doing is something that needs to be done, right? To bring this mainstream software stacks that are out there for 30, 40 years. We can't just throw that away and like hundreds of millions of people who develop. And we need to get those guys into the game. And but our core goal is to get the technology out so that people can build things on top of it, right? And as much decentralized as possible and trustless as possible. That's
okay. Guys, can you please ask your questions on the voice chat? It's open now. You can raise any questions and we'll answer them. So Milton, do you want to tell them where they should follow you or where they should, what are the channels where all your hot, fresh information is received?
Yeah, I guess the best way to follow us, there are the Telegram channels, but I would suggest the Discord channel, which is more technically oriented. And there we are around to answer any questions for people who are developing and trying to develop. I would like to suggest as well to go to cartesi.io/labs. You can apply for a grant program in Cartesi Labs, where we are helping, we're funding and mentoring projects to be developed on top of our tech and help us polish our tech to get to the next level of adoption and convenience.
Guys, voice chat is open. We'll wait for a couple of minutes and see what the community thinks.
All right.
Tell us something about the Cartesi machine to that.
Right. So the Cartesi machine is something really special in my personal view. It's a self-contained, fully deterministic RISC-V machine, virtual machine, which allows you to perform any computation. And running Linux. It's fully transparent, and so you can at any point inspect the full state of the machine, and that includes the memory, it includes the registers, it includes the file system, and everything that's in the machine, and it can produce a hash of that state. So at any point, if there's any divergence between anything, that will produce a different hash. And since we use Merkle trees, we can actually prove whether a given a hash of a part of the machine is compatible with the full state of that machine. So this is the basic characteristic that allows us to, and since it's deterministic, you get the same input, you will get the same output. So you get the final state hash, exactly the same thing if you run it again and again and again in any machine. So that's the basic mechanism that you get. If you run it and you get different hashes in the end, then somebody did something wrong. And the way we solve this is that you have an interactive dispute mechanism. So you can find exact instruction where the people agreed on the state before that instruction and disagreed on the state after that. And we have implemented the same architecture on Ethereum. So you can run this one instruction on Ethereum, just one, and you can produce.
I think we lost him. He'll be back momentarily. He's raising his hand, Sandeepan, and yeah.
Yeah, I have it. Yeah.
Sorry, Milton.
Yeah.
Go on.
Not sure which part you didn't get, but so you can run this instruction on the blockchain, right, on Ethereum, and know which one of the users of the machines in the scale of the nodes was right, because you run the one instruction that migrated from one state to the other, and you know which one is right. And so if you get one honest guy, he can prove himself right to anybody else. You can have 1 million guys trying to cheat, and you can still prove yourself right. So you have any trust guarantee. That's the basic feature that we have in our project.
Congrats to your team for this. Why did you guys choose Polygon? Just out of curiosity.
Well, we really like you guys, and it's fast, it's cheap, it's convenient, and it's a real great place to be to get these smart contracts deployed. Both the core ones, right, that do this validation, and also any subsequent ones that we want to build on top of it, as is the case for this turn-based game framework that we did. Yeah, Polygon pushes the limits of Ethereum further, right? So we can, and we are in our poker game, we are pushing those limits to the limit, really. So we are sending some tens of kilobytes of data sometimes here and there, and Polygon can handle that. So that's really great.
That's great to hear.
I think people have already started checking out the Cartesi's platform, and their website is actually interesting. Like, so
okay, so I think we can wrap up now. Thank you so much for your time, Milton. You guys are doing some crazy, interesting things, and I'd request everyone in the audience to go check them.